Hello everyone, and welcome back to Transcendent Philosophy. Today we're going to be discussing free will, and in the context of Kevin Mitchell's book. Right here we've got his book, Free Agents, How Evolution Gave Us Free Will. Look at this stud. He's a neuroscientist. He's got an interesting perspective on free will. But a little bit of context. Free will, there's a complicated debate. It's very semantic. And so we need to make sure we know what we're talking about in terms of terminology. So check out this blog, Free Will Definitions, if you're unclear. Otherwise, we'll go right on ahead. The robot touchstone. Touchstone is kind of just a word for a philosophic test. Its origins is from testing metallic purity. There could be fake metals and like pure metals, and you like rub a stone against it and you see like markings on the stone and you can tell if it's a real metal or a fake one. So it's kind of like it's a test for a benchmark or a threshold, right? It's metaphoric. So when I say the robot touchstone, we're talking about a test, and so basically the robot thing is the fake metal and the free will is the true metal, the pure metal. And so we're trying to distinguish the fake from the real, right? And so the idea here is when we're trying to evaluate if free will exists, my test is let's rub something against your evidence and let's see, is it a robot or is it something that transcends what a robot can do, right? So I think there's a lot of examples, lots of silly examples, right? Where people, like if you challenge someone's free will, right? You're like, I don't think free will exists. Well, people get defensive, like, of course free will exists. And then they'll do a random movement, or they'll like grab a piece of paper or grab a pen. They'll be like, see, look, I did something random, therefore I have free will. And then so the robot touchstone, it's like, okay, you did something random. Let's, rub the rock against it and test. Could a robot do that? Could a deterministic robot that's a slave to its programming, could a robot do something random? I think it could. There's random number generators in video games. You can make a robot do random things very easily. So, fail. That is not free will. That's something a robot can do. So that's the point here. You have to transcend and go above and beyond what a robot can do in order to satisfy the threshold for free will. Because, I think that's what the whole debate is about. When people are discussing free will, they want to know that they're more special than a robot. That's the core issue. People are offended because they want to feel divine. They want to feel special. They want to feel that they are above and more powerful than their materials, right? And it hurts their ego to think that they are limited in some way. And so they have this egoistic desire. But the question is, what's the truth? Like, facts don't care about your feelings, right? Like, what is the truth about our nature? Are we magical? Do we transcend our materials? Or do we actually follow our materials like a robot? It's an important distinction. No matter how insulting it is, if we want to make the world a better place, I think we have to know the truth first. Truth precedes goodness. And if you don't have the truth, you're never going to get to goodness because you're going to be blinded and lost by falsehoods. So that's the fundamental debate. That's what people are worried about in this debate. And now we have the compatibilists. The compatibilists basically want to just redefine free to mean the same thing as robotic. They're like, oh, determinism is compatible with free will. So you can be this deterministic robot that is a slave to its programming, and we're just going to slap the label of free on top of it and pretend like you didn't see the sleight of hand. Like, what? Like, since when is being a robot the same as being free, right? That's when we're talking about free will, the will, that's our neuroscience. That's how our brain is operating. Is our brain a slave to what happened before? Is it a slave to the laws of physics? Is it a slave to its algorithmic structure? Is it a slave to the materials? Or does it somehow transcend that, right? Because robots, they're just a slave to the procedural movings and processing of their material algorithms. So yeah, the compatibilists, they just kind of screw up and confuse the entire debate by just conflating robotic with free. So for my purposes, I want to completely separate the two, juxtapose them against each other and say, no, free means the opposite of robotic. Stop it. Stop it. They're not the same. So that's my opinion on the free will debate. And, there's so many other adjectives. Like, come on, compatibilists. Why? Why are you obsessed with the word free? Like, I don't care about the tradition, the history. No. Let's be clear and precise with our language. If by free you mean algorithmic, don't say free will, say algorithmic will. If by free you mean intentional, get rid of free and say intentional will. Yeah. If you're talking about like reinforcement and, we can be conditioned, like our will can evolve and change through, psychological conditioning, don't say free, just say conditional, a conditionable will, right? Give more accurate adjectives, because free, when we're talking about free will, we're talking about being free from cause and effect. Determinism, the chain of events of determinism. That's what we're talking about. Are you free from that? And so they're just changing the subject and talking about agency. So if you want more context on that, go check out the free will definitions. All right, so let's classify Kevin's stance in this debate, right? There's the three main positions: compatibilism, libertarianism, and hard incompatibilism, right? So I'm a hard incompatibilist. I believe there's no free will and it's incompatible with everything, right? It's incompatible with determinism. It's incompatible with indeterminism. So no free will. That's my stance. The people who believe in free will, it's either libertarian or compatibilist. And the question is, which one of those is Kevin? Compatibilists believe that free will is compatible with determinism. Kevin situates himself firmly against this stance because he goes to great length to attack the idea of predeterminism and just says predeterminism is absolutely not compatible with free will in his view. So if Kevin is not a compatibilist, does that make him a libertarian? Kind of, depending on your interpretation. So libertarianism, they think that free will is incompatible with determinism, which means we have to have indeterminism, right? The opposite, the logical opposite of determinism. We must have indeterminism under the libertarian free will paradigm. Now, then the question is, what is indeterminism, right? And so if determinism means everything has causes and there's a flow of causation, indeterminism is often interpreted as just randomness, but often libertarians, they don't want to appeal to just randomness, right? So the average person who believes in free will, that this libertarian free will, they kind of just believe in like a soul. They're like, oh, well, I'm not a determined robot. I'm like this divine soul. And that's where the freedom comes from. And these types of people have often not thought very deeply about it. So the casual libertarian is like, I got soul powers, dude. That's the free will. And then like maybe a little bit more rigorous libertarian will be like, well, instead of a soul, we've got like this metaphysical agent. And so we've got agent causation, right? So they're not talking about randomness. They're talking about like this organized power of causation, right? The soul, the agent, organized causation that gives them the free will. But Kevin, he's not really going that route, right? Kevin, he rejects the soul paradigm completely. So Kevin, he embraces this randomness perspective, right? So a lot of his argumentation revolves heavily on how randomness helps give us free will. And so he kind of is in this hybrid stance space where he doesn't accept the soul paradigm and he doesn't accept the determinism paradigm. You can kind of summarize Kevin's belief in free will by saying the following. Kevin believes that free will is compatible with a mixture of determinism and randomness. That mixture is what gives us free will, according to Kevin. So as I went through Kevin's book, I tried to pay attention to different points in the book that were very poignant and characterized his stance. So I tried to aggregate a bunch of quotes from his book And then it just turned into a really long aggregation. So I'm like, okay, I got to simplify this so I can address it point by point. And then I got a bunch of points that were chaotically spread out. I'm like, okay, this is going to be horrible to like just film all these chaotic, ideas. So I need to organize all of Kevin's ideas into topics. And so that's what I did. I kind of summarized each point, and then I categorized it, and I made a list. So I'm trying to do a very thorough job of respecting this book. I'm respecting his perspective, trying to represent it accurately, and then give my opinion on each point. So I've organized a table of contents where we've got his perspective on agency, and then some of the evolutionary features of this agency that we've evolved, and kind of the relevance of meaning and reasons to his paradigm, how he thinks about configuration, right? Neurological configuration, a very robotic word, you'll notice. And then Kevin's perspective on needs, values, goals, options, and selection, some of the ingredients of the decision-making process, very important. And then his perspective on algorithms in general. And then we've got necessity, randomness, and will, how those interplay with each other. And then we've got a lot of interesting perspectives on predeterminism. And then we've got randomness of the interneurons, where he looks for in the brain for randomness, and how his perspective on the importance of this randomness. Then we've got a couple ideas about top-down causation versus bottom-up causation, kind of my interpretation of his interpretation. And we've got morality and responsibility. And then we've got the conclusion, and the references are just the quotes from the book that I'm appealing to. So first topic is agency. Kevin Mitchell believes bacteria can be classified as agents. I agree. I think, so for me, agency is a very low bar, very low threshold. Free will high, agency low. Very easy to have agency. What is agency? It's the ability to act. And what does it mean to have the ability to act? Well, we contextualize actions in relation to goals, right? If you're acting, why are you acting? Well, you have a goal and you're acting to progress towards a goal. So action implies goals. So agency implies goal-directed behavior. And so bacteria, do they eat food? Okay, so they have a goal. They don't want to starve. So they see some food and they go move towards the food and they eat it. Okay, that's an agent. Not super complex, not super special, very low bar, easy to pass. Yes, bacteria can be agents. Does bacteria have free will? No. So one of the things you'll find, often Kevin, he kind of bounces between libertarianism and compatibilism, and because he's conflating free will with agency, right? And that's one of the things you have to watch out for. He does this shift where he's kind of like, he wants to like equate the two. I'm like, no, you cannot equate the two because robots can be agents, but robots cannot have free will. Remember the robot touchstone. If what your evidence for free will is replicable in a robot, that's not free will. That's just agency. Okay. All right. So Kevin, he goes in to describe what he thinks, some features of what he thinks comprise an agent. So what we have here, the first is they have real autonomy. Not fake autonomy. They have real autonomy, guys. What does that mean? So I have a big issue with the word real because it seems like he's just smuggling in like magical freedom inside the word real. Like, what are you doing with that word? We can have autonomy, right? Or we can have real autonomy. Okay, so big red flags for me on the word real. Seems a little magical, not gonna lie. Robots can have autonomy, but it's not real in the magical sense of being free from the laws of physics. No. So for me, agents, they have autonomy, but not real free autonomy. Okay. All right. So I have issues with his first criterion of agents. Second criterion is agents are organized. Perfectly fine. Nothing wrong with having an organized agent. But guess what? Robots are organized agents, not free will. Okay, agents, they also have dynamic patterns of activity, right? I mean, dynamic, it just means like complicated fluctuation of variables, right? You put them in a different environment, they fluctuate into a different pattern. Put them in this environment over here, they fluctuate into a different pattern. You can do this with AI, you can do this with robots, you can do this with NPCs. You take a video game character, like a robotic video game character, put them in a different environment, they behave differently. Put them in a different environment, they behave differently again. So that's not special. That's not something that transcends robotic programming. So dynamic pattern of activity, it fails the robot touchstone. It's not free will, but it is agency, so that's fine. So this next one was really interesting to me. He says agents have to be causally insulated. It's like, that's a really interesting criterion of an agent, right? And at the level of bacteria, it's really important. Bacteria has a cellular wall, right? So that's fascinating. Like bacteria, they build a barrier. And so there's the external environment, and then there's the internal environment. So the bacteria, it insulates and protects itself from the external world. And then inside the bacteria, they can run these little biological algorithms. They got little DNA going on, and they're processing the DNA. And that insulation, it protects the brain of the bacteria. Like, okay, that seems important. Okay. And it's a shell, right? You've got the code and it's protected in, yeah. So, I mean, I think this still falls under the robotic paradigm. It's like you've got the robot code, and the robot code is insulated in this protective shell that makes it, able to do its algorithm without interruption by external factors. Okay, that's cute. That seems valuable for an agent, right? If an agent wants to accomplish his goals, he needs to protect his algorithms. Sure, agents need to be causally insulated. But this is a function that robots can do. And so it's not a standard for free will, it's a standard for agency. And the other interesting thing is, in this universe, nothing is perfectly causally insulated. So yeah, and there's chains of cause and effect despite insulation. So you're never free from chains of cause and effect, no matter how insulated you are. So you're never going to get free will with this attribute, but you can get relative insulation. So that's cute. That's a cute angle to think about. The next attribute of agency is configured to maintain themselves. Okay, this is a very interesting aspect of agency. This, I would say, is a feature of autopoietic agents. So autopoiesis is the ability to maintain yourself and to propagate oneself. So life is a self-propagating system of agency. But you don't have to have autopoietic agents, right? So to me, he's describing life here. So he's kind of, to me, this is an optional aspect. So this is like, if you're wanting to level up your agency, you want to add autopoietic features, right? So these are nice additions to agency. These are not necessary for agency, right? These help you be a better agent, but you don't have to have it to be an agent. A robot is an agent even without autopoietic features. Okay, so configured to maintain themselves, not necessary, but nice. Nice addition. Makes a really good agent, right? But, robots could be programmed to maintain themselves, and robots could start to evolve if we developed them in that direction. But they don't have to. And being configured to maintain yourself, it makes you a really good robot, but it doesn't give you free will. So again, great for agency, not sufficient to pass the robot touchstone test. And, just one thing that needs to be said is that, I have a software background. One of the easiest things to do in coding is to make a goal, right? It's one of the easiest things. And so agency is the ability to have a goal. And like the dumbest software engineer can make a software agent that has a goal. Extremely easy. It's just a while loop. Like keep doing the thing until you accomplish the goal. Once you accomplish the goal, hooray, you've accomplished the meaning of your existence, right? Super easy. Make a while loop. Okay. So next one is ability to learn. It involves memory. Again, this is not a necessary condition for agency. This is just a nice way to level up your agency. Makes you a better agent. The more you can learn, the more you can remember, the better you can act, the better you can accomplish your goals, right? So it makes sense that agents will evolve to become better agents, which involves better ability to learn, better memory, and there's a spectrum, right? You've got better and better agents. Very normal. This is something robots can do, right? GPT, it's a deterministic algorithm, but it's able to learn, it's able to have memory. This isn't that special. It does not pass the robot touchstone test. Yes to agency, no to free will. The next criterion is the ability to act on the world. Yes, actions are fundamental to agency. But guess what? Robots can act. Not that special. Goal-directedness. Yes, this is the most fundamental aspect of agency. But the same thing, robots can do it. It's not free will. So yeah, goal-directedness, that's basically the main criterion, and everything else is just additional spice to make it a better agent. Next point. Agents are loci of causation. They're a locus, a nexus, a source of causation. How do I feel about that? So the problem is he's flirting with this soul concept, right? He's flirting with libertarianism, this magical idea of like a disembodied agent or a disembodied soul, right? He's flirting with that concept here. He's like, the agent is the source of the causation. What does that mean, bro? Right? He's acting like this agent, it transcends the laws of physics and it's in this metaphysical space. And this agent metaphysically looks down on the materials and starts, manipulating and puppeteering the materials of the body, right? Like a top-down causation from the soul. So he's flirting with a lot of sketchy ideas right here. Metaphorically, sure. Physically, no. There's no metaphysical causation. It's all materials moving around. So, and I've listened to him on podcasts where he makes it more clear than in his book. He is, for some reason, fine with spooky causation, right? Like a philosopher interviewed him, was like, well, don't you feel like there's like, there's the, local causation in the laws of physics. Like this material acts on this material. And there's a chain of material interactions. And he for some reason, he like rejects. He's like, no, there's something that transcends these local causations. What is that, dude? You're a neuroscientist. What is that non-local causation? Spooky, right? We're going to get there. A little spooky. What do you mean, bro? Next point. According to Kevin, agency means having behavior that is not completely determined by any given physical stimulus. Okay? What Kevin means is responding the same way to stimulus every time is the opposite of agency. What's an example? If I prick you with a needle, and if you flinch every single time, that's not an example of agency. According to Kevin, responding with an ouch is evidence of robotic behavior. Or for example, doctors, they'll like do the hammer on your knee and they'll trigger the reflex and your leg will pop forwards. According to Kevin, that's not agency because it's the same thing every time. So Kevin, he's kind of like flirting with the idea that that's a robotic behavior, and he agrees that robotic behaviors are not. Okay, now, according to Kevin, robotic behaviors are not free will and they're not agency. Why? Because he conflates free will and agency. He thinks they're the same thing. Oh, stop it. Why are you conflating those two things? No. Okay, so let's disentangle all this confusion that Kevin is doing here. Agency means doing the robotic thing. So he's saying that agency is not doing the robotic thing. Wrong. Agency is doing the robotic thing. So actually, it's fine to respond the same way every time, right? Because agency means accomplishing a goal. And if the goal is pain avoidance, it's fine to flinch every time you're stabbed by a needle because you're trying to avoid the needle. That's perfectly fine for an agent. You're accomplishing the goal, right? No issues. Now, the fact is that is not compatible with free will, because you're doing the robotic thing, you're accomplishing the goal, but you're not free. You're actually a slave to the goal, okay? So that's fine. That's fine. So what we need to do is to change what he's saying. What he's saying is free will means behavior that is not completely determined by any given stimulus. Great. Perfect sentence. Don't conflate agency in there, bro. Okay. So, yes. Yes. So, yes and no. Both, depending on how you build the sentence. Sorry. That was nightmare. Next point. Agent causation transcends physical causation in that agent causation is based on information and not on physical stimulus. Okay, we've got kind of a cute distinction here. I'll give him cute distinction. So we could think of physical causation as just materials. It's like a planet bumps into a planet and it's like cause, effect, outcome. It's like very simple. Or like, I get hit by an obstacle. Two materials collide. Okay, that's a physical stimulus, right? So physical causation based on physical collisions. Sure, nice and simple. Now, agent causation is based on information. They're processing data. Like, how does this data affect my goals? Okay, and now I do things based on processing the data to navigate towards the goal. Okay, that's cute. But again, robots can do this. Robots can process information all day long. That's what they're doing. The robot or the algorithm, the computer or the NPC video game character, they're not responding to electrons. They're not like, oh, electron bumped into me, and so now I'm going to bump this. No, they're actually processing the context. Like, okay, I'm playing chess. The human moved here based on the context, process all the variables. I got to move here. They're operating on macro level information that they translate out of the materials. Same as us, not that special. Robots can do it, not free will, but it is agency. So I will grant it to him as long as he's not conflating agency with free will, which he is. Stop it. Last point here in the category of agency. Agency includes the ability to learn. I mean, not necessary, but it makes a really powerful agent. Cool. Yeah, something robots can do. AI does this all day long. It's literally called machine learning. They learn the data and then they build the patterns and then they can act on those patterns. So if again, you've met the agency threshold, you have not met the free will threshold. And there are 2 points here that, yeah, maybe these could have been lumped under the agency category. He's got more ideas about how agents should function, some features that they should have. Again, to me, these are just things that make a better agent, not necessary, but evolution makes better agents. So it makes sense that life has these features. So perceptual systems must subtract agentic biases from perception. Like, what does that mean? What he means is like, as you turn your head, you don't want to, get confused by your head moving and the data moving. And so you kind of have to modulate the data. So it's not like, oh, did we move this way? No, we didn't move that way. We're just looking this way. So it's like the next point here, you have to include a model of yourself and a model of the world and a model of your relationship to the world. I mean, these make good agents. You want to navigate properly. You got to have good models in order to navigate. And, if your biases are going to confuse you, you've got to tweak your biases so that you can navigate properly. This is nothing that algorithms and robots can't do. Every time you train the data on a AI algorithm, you're tweaking its biases all day long. Every single model has different biases. And so the question is, oh, are these bad biases? Okay, let's train the AI, let's feed it more data, and let's tweak its biases to a more optimal state. Nothing non-robotic about that. And modeling itself in relation to the world. I mean, these are advanced robotic capabilities, but like this is nothing robots can't do. Video game robots do this all the time. Meaning and reasons. Kevin Mitchell keeps bouncing back and forth between this compatibilistic robotic view of humanity and this libertarian transcendent view of humanity. So when he talks about meaning, he's like, meaning evolved from approach-avoid calculations. Dude, that sounds totally robotic. Like, you calculate this pathway, I get X number of utility points. That pathway, I get negative utility points, and I navigate. Totally robotic. I mean, there's nothing special about that. Yes, agency, no free will. Now, there's consciousness, sentience, pleasure, and pain, right? Those are special. I will grant specialness to sentience all day long. But I don't think that the causal function is special. So I need to clarify this because this is an important distinction. For sentient creatures, I think that pleasure, so the feeling of pleasure is special, but it reduces to approach utility points. So basically, the mathematics of evolution creates pleasure, and what pleasure means is approach, because good things for evolution. So you see food, and then your evolutionary algorithms, they're like dopamine, pleasure, go to the food. It's really good for you. Why? Because it helps you exist, and that's what evolution wants, okay? So pleasure is the product of a algorithmic calculation, in my view, which means that pleasure does not transcend the robotic paradigm, right? If pleasure is a type of calculation, calculations are algorithmic, algorithms are robotic, we're still in the robotic paradigm. Pleasure, pain do not transcend the robotic nature. Now, do I believe that robots experience pleasure and pain? No, I do not, okay? So in my view, there are at least two types of robots, right? There are the sentient robots and the non-sentient robots, right? The distinction being sentient robots can feel things, unsentient robots cannot, right? And how we get feelings, that's a complicated question. I think it's a question of biology. I think it's a question of physics. I think certain circumstances can create sparks of feeling, and certain circumstances do not create sparks of feeling. And so for the normal ones and zeros robot, I don't think ones and zeros are complex enough to create sparks of complex feeling. But I think biology is rich and diverse enough to create the context for sparks of complex feeling. That's my paradigm of sentience. That's the distinction. The takeaway is, yes, agents, robots, right? You could have agents with pleasure and pain that motivate them to the goal, which is an agent, a robotic agent. Or you could have ones and zeros that motivate a robot to the goal, and that's also a robot, that's also an agent, but it lacks the sentience. So the two types of robots, neither of them have free will. Consciousness, sentience, does not change that fact, at least in this context and paradigm. Next point. Cognition evolves to represent information in terms of meaning, not directly acting on perception, but instead acting upon meaning extracted from perception. Okay, so he's basically saying that Agents have a thing called cognition, and cognition is super cool because cognition takes in the data from perception and it translates it into, meaning. And meaning is, ooh, this pathway is pleasure. Oh no, this pathway is pain, right? Meaning, okay, fine, sure. Robots can do that. I mean, complex algorithm, yeah, not every robot can do it because this is high-level programming. This is advanced, but it doesn't transcend the algorithm. It's just a good algorithm, an advanced algorithm. So, yes to agency, no to free will. Next point, learning and memory allow agents to act on their own reasons. Okay, so it's like, oh, GPT, it learns something. It learns something about you, context. And then it acts on what it learns about you based on your interests, based on your history. It tailors its message just for you. It acts on its own reasons. It acts on a database of data it's collected from you, which it now owns. And it owns the reason. So it's their own reason, right? Still, you have not transcended the algorithmic paradigm. You're still in robot territory. So, yes to agency, no to free will. Next point. There is a hierarchy of neural processing that is extracting meaning from perceptual data. That's fine, but there's hierarchies in software all day long. Hierarchy of processing is not unique. Software can do it, AI can do it, robots can do it. It's not that special. So yes to agency, no to free will. All right, his next point is this strange assertion. I find it strange. Like when reading the book, I was like, it just kind of popped out of nowhere with the justification was really weak. It's not that clear what he even means. He just says, reasons exist at the level of the whole organism, not its parts. Like, what does that even mean? Like, if I'm afraid of snakes, it's like, is there fear of snakes is a reason to stay away from snakes? Ooh, I'm acting to, distancing. It's an action. Does it mean fear of snakes is like at the level of my whole body? Like, is there fear of snakes in my knee and in my knuckles? And like, it's just all over, like fear of snakes, it's just all over me. Like, is that what he means? Like, that's a weird phraseology, dude. Like, the algorithmic perspective is you put the reasons in the spot that they need to be for the algorithm. So like neuroscience, you're a neuroscientist, dude. The fear is in the amygdala. So like, as you're processing the data, you're like, should I be fearful? I don't know. Let's go see what the amygdala has to say. And so the pattern of data, the consciousness, it goes into the amygdala, energy is flowing. And you're like, based on the database of fears in my amygdala, I should be afraid of snakes. Boom, trigger all the hormones. Oh, bodily reaction, fear, avoidance behavior. Okay, that makes sense to put the fear in the part of the algorithm that needs fear. That makes sense. Whole organ. What are you talking about? I don't know. That's weird. All right, next section. We're going to be talking about configuration. Yes, love this. Configuration, what a topic. Very robotic topic, but a cool one. Okay, so this first point here, Kevin talks about the difference between the stimulus and the configuration. So stimulus, your sensations. You're a human, and then something touches you. You're like, oh, stimulus, right? Okay, your reaction. Okay, so what Kevin is saying is the stimulus, it might be the ultimate cause of your behavior. So he's granting the stimulus causes your human behavior. Interesting thing to grant, Mr. Kevin. And then he says, but the configuration of the organism, that's what, it's based on an interpretation. So, sorry, I'm confusing this. The configuration of the organism is the more proximate cause, and the configuration of the organism is what affords the extraction of meaning, right? So it's like, I look out into the world and I see a bunch of pixels of data. So the stimulus on my eyeballs, a wall of pixels. Bam! I'm hit with all the stimulus. Okay. Now, my brain has a configuration and it's looking for patterns, right? And back to the snake analogy. Ooh, there's a pattern of a snake on the ground in my visual sphere. So the configuration of my brain, it highlights the shape of a snake. It's like, warning, warning. Like the neurons that sense this shape are like, bam, bam, bam. Send data to the amygdala, send data to the, boom, fear reaction, right? So your fear reaction, technically the ultimate cause is the visual data, but there's an in-between cause because there's a chain of cause and effect. First you get the visual data, then you process the visual data, you get an interpretation of a snake, and then boom, you act on the interpretation of the snake. So proximate, like the interpretation is closer in algorithmic space. It's closer to the actual behavior. So you're like, oh, he's acting like, well, that means that's free will. Is that what that means? So, I mean, we're back to this whole robot paradigm where robots, they can have a hierarchy of interpretations of data all day long, and then they come up with some interpretation of the data, and then they act on it. So yes, very algorithmic, no problems there. But free will it transcends all of this. When we say we have free will, we're saying, I'm not a slave to the stimulus. Like, I can do what I want, right? I'm free from, I'm not a robot program that's just ones and zeros, output of behavior. Free will is, I'm not whatever that is. But what Kevin's describing is just exactly that. It's just processing the data and outputting a behavior. So he's granting that we are a slave to this ultimate cause, and free will must transcend slavery to ultimate causes. That's all there is to it. All right, this next one is kind of fun. I call this. So what I did was, there's a part of his book where he kind of plays with some ideas. And what I did was I reorganized Kevin's thoughts into a syllogism, or two chained syllogisms. And I'm naming this for Kevin. This is the configuration argument for free will. Okay. Now, it's not exactly how he describes it, but it's my best attempt to represent kind of what he's implying. Okay. And obviously the sources are at the bottom, so you can go see Kevin's own words and see if my interpretation is fair or not. All right, configuration argument for free will. Premise 1. Structural organization can do causal work. Okay. I mean, what does that mean, right? What do you mean? I mean, so in my opinion, this is fine. Structural organization can do causal work. That just means that your material structure affords cause and effect. Like, doing causal work means you create an effect by being a cause. So the structure does an effect. Okay, you're just a cause in a chain of cause and effect. Very normal. A domino has a structure. There's a material structure for the domino. We flick the domino. The shape of the domino, the size, the weight, all the variables, the structural organization of the domino does causal work. Brrr. It's a chain of cause and effect. The problem is this is not that special. Okay, so premise 2. We are our structural organization. I think this is fine. You can, like the self, right? What is the self? I mean, you can play with definitions. I think it's fine to define yourself as your structural organization. Reasonable definition. Who cares? What's the point? Oh, conclusion. We, ourselves, we can do causal work. Causal work, bro. I mean, dude, it's not that special. Yes, you can be a part of a chain of cause and effect. Congratulations. That's a domino. Okay, so now there's kind of his implications, or what he's trying to imply, that if you do causal work, you got free will, bro. I'm like, no, that's the problem. The problem is he thinks that causal work is special. Rivers do causal work. Oh, a river, it's got a structural organization. And cause and effect, it's pushing things down the river. Oh, it's powering our energy. Yes, structural organization gives you cause and effect. No free will, bro. So that's the problem. Next topic. Needs, values, goals, options, and selection. Lots of stuff packed together, interrelated. First point. The list of current needs to evaluate potential actions against is stored in the hypothalamus. Okay, so what you need to think about is, okay, we simultaneously have many goals. We've got biological drives. I need to pee. I need to sleep. I need to eat. I need to play. I need to work. I need to... Long list. He's saying all of those needs are listed and stored in the hypothalamus. Okay, so lists, it's software can do lists. Software can evaluate needs. So sure, I mean, that's great. Humans do it too, but this is not that special. Next point. Hypothalamus signals intensity of needs, but not how to satisfy them. Okay, that's great. Intensity of needs. I mean, that's such a basic piece of data. It's like, oh, here's a need, and we're going to give it an intensity of 10. Here's another need, we're going to give it an intensity of 20. Here's another need, we're going to give it an intensity of 30. Okay, software, which action should we do? I don't know, which one maximizes our utility points? Okay, we're going with the option to get 30 points. Super basic. Nothing difficult about this in terms of algorithmic agency. Next point. Goals reside in the cortex. Long-term goals reside in the prefrontal cortex. Cool. Like, that's how neuroscience works, apparently. Goals are not special either. Next point. Agents internally simulate potential actions, weigh the simulated outcomes against their goals, and select the action that provides the highest utility. Okay, you've described a utility maximizing decision function. Like, any video game character is going to need one of these algorithms. Which way does the NPC go? Right? That's pretty basic. Next one. All agentic actions are inhibited by default, and then a chosen action is allowed by overcoming the inhibition system. Okay, he's describing how the brain works. It's actually fascinating. There's a lot of brain activity is inhibition, which is to say a lot of the brain, the point of the brain activity is to turn off the brain, to turn off the flows. So there's flows that turn things on, and there's flows that turn things off. That's fascinating. But back to the thing, it's not that special. Like, I'm not an electrical engineer, but I'm pretty sure this type of phenomenon is pretty common. Like, they literally have resistors in electrical engineering that are resisting the flow of the electricity. And you have to take certain actions to open up the pathways to allow the flow of electricity. So it's like inhibition and then turn things on. Like, that's how the brain works. That's how electricity works for software and for hardware. So next point, agency is located in nested circuit loops between the cortex, the basal ganglia, and the thalamus. Okay, so to me, like, you're just saying the biological algorithm is here, here, and here. Like, it's got to be somewhere, so that's fine. Next point, agency involves assessing the situation, monitoring needs, prioritizing goals, conceiving of possible actions, selecting an action, and learning from outcomes. Back to the, yeah, that's what agency needs to do. That's not what free will does. Next one. Options would be represented as patterns of neural activity in the cortex, and in the basal ganglia, and in the thalamus, and in the midbrain. So you've got smatterings of option data throughout the brain. And so your brain is, oh, options over here, oh, options over here, processing all the options. An agentic algorithm would need to do that. Yep, that's good for agents, not enough for free will. All right, next topic, algorithms. All right, he makes a somewhat provocative statement, but I actually agree with him. He says, we are not step-by-step algorithms. Okay, step by step. What does he mean by that? Okay, so basically what he's saying is we are not simple algorithms. I mean, technically you could have a complex step-by-step algorithm. And I would agree that we're not complex step-by-step algorithms either. And that's because the shape of our biology is not linear, right? Step-by-step implies linearity. Right? Think about a bacteria. Okay, bacteria, it's a sphere. And so the sphere has like little receptors all over the sphere. So it's like each receptor is like a stimulus that is the first step in an algorithm, right? So imagine a sphere and imagine 100 receptors on the sphere. Okay, so you've got one causal chain on this receptor, then you've got another causal chain on this receptor, then another causal chain on this receptor, and another causal chain. You've got simultaneity of multiple causal chains. So that's not a simple linear step-by-step. It's a multiplicity of causal chains in a spherical ontology. Okay, that's complex. But you're not escaping chains of cause and effect. You're just multiplying the number of chains of cause and effect, right? So, so basically, yes, we're complex algorithms, but complexity does not afford free will. Or multiplicities of causal chains does not afford free will. Like we could, dominoes are super dumb, but you can make them complex. You can say, oh, here's a causal chain of dominoes, here's another causal chain, here's another causal, and our causal dominoes are gonna interact with each other. There's a nexus where multiple chains of dominoes are coming, and then it's like, ooh, interesting, multiple causal chains. That's not free will. Sorry, it's cool. It's complex interacting algorithms. It's not free from chains of cause and effect. Next point. We are neither spirit nor mechanical machine. Our self is a dynamic system, and that dynamic system is making decisions. Okay, dynamic, we've talked about before, not that special. Yes, it's complex. Yes, it's interesting. Yes, it affords adaptability because, oh, it's context dependent. Put it over here. It does something different. It's evolving its pattern based on internal loops of variables and processing. And that's, complex AI models can do this all day long. Next topic, necessity, randomness, and will. All right, Kevin, he quotes from ancient Greek philosopher Epicurus. It's kind of a cute quote. It's basically, he's emphasizing that necessity is not everything. So in the universe, it's not just necessity, which is determinism. This cause necessitates this effect, necessity. So he's saying cause and effect isn't everything in the universe. Some things are accidental. Ooh, we could interpret accidental as randomness. And then Epicurus says some things are based on will. So he's got a trichotomy, necessity, randomness, and will. All right, here's the problem. In logic, you've got logical opposites, right? So determinism is one thing. The logical opposite of determinism is not determinism or indeterminism, right? So it's either determinism or indeterminism, two options. And so those options should contain all of reality, right? That's how logic works when logic is working. Okay, so if necessity is based on determinism and accidents are based on indeterminism, then the universe is this dichotomy. Perhaps there's a mixture of both, and we got this mixture ontology, right? This mixture reality. That's fine. All right, will, if everything is either determinism or indeterminism or a mixture, will has to fit that paradigm. So will has got to be, it's like will is determinism, or will is indeterminism, or will is a mixture, because that's all there is, right? Will has to be somewhere in this mix. So the main problem is this paradigm, like it's not just, where's the freedom, right? Where's the freedom of the will? I mean, it's really, the problem is deeper. The real problem is like freedom implies randomness. Will implies determinism. That's the deep problem. So if you try to dissect what this means, when you say free, you're saying, oh, I'm not controlled by chains of cause and effect. And then when you say will, you're like, I am affecting what I want. It's like, if you affect what you want, the effect requires a cause, but by default, and causes require causes. So the will implies determinism. The freeness implies indeterminism, and that is what you call a contradiction. And what did Aristotle teach us about contradictions? The law of non-contradiction. If something and something its logical opposite, they both can't be true at the same time in the same way. So if a concept contradicts itself, like if you say, I believe Bob exists. What's the definition of Bob? Well, Bob is both A and not A being a variable. Well, that's a logical contradiction. Bob can exist. So, for example, a married bachelor. Well, Bob is a married bachelor. Well, married is A, bachelor is not A. Whoa, we've got an internal contradiction. Bob cannot exist because he's self-contradictory. That's the problem with free will. Free will is a married bachelor problem. Okay, I'm going on a rant here. Basically, who cares what Epicurus says? He did not solve the problem. All right, this next point is so cute. It's so fun. I just love this one. This is like a Jordan Peterson take. All right, this is also finishing the quote from Epicurus, right? Epicurus just threw this out there, a little zinger, right? It would be better to follow the myth about the gods than to be a slave to the destiny of the physicists. All right, what does that mean, right? The myth about the gods. See, this goes into what I was saying earlier. These libertarians, they're being religious. Like, they try to hide it. They're being religious. The myth of the gods. He's saying, oh, the gods, they gave us the freedom and the free will, right? And the physicists, they're trying to rob us of our freedom. Oh, those evil physicists. Now, the physicists are just pointing out the truth. It's like cause, effect. Everywhere we look, it's chains of cause and effect. Did you do your empiricism, bro? Look out into the world. Observe what's going on. Cause and effect. It's everywhere. It's like, well, we don't like physics. We want to believe that we can transcend physics like the gods. Okay, guess what? Facts don't care about your feelings. So, and my argument is you should care about the facts more than your feelings, right? Pretending you're not a slave to the laws of physics does not give you the freedom to defy the laws of physics, right? So this is a fun example, right? Like, you can believe that you can defy the laws of physics. You can believe that you can fly. But guess what? Believing false things is going to lead to some really bad outcomes, right? If you jump off something because you think you can fly, you're going to get really hurt because you have a false belief about reality. That false belief is leading you to bad decisions. So this is why truth is more important. First, let's get the facts straight. Then we can try to navigate to good decisions. And if your whole philosophy is, I want to believe lies because they make me happy, you're going to make a lot of bad decisions. You're going to guide the world in a bad direction because you're disconnected from facts. Truth precedes goodness. I don't agree with that pathway. Maybe I'm wrong. I don't think that's the right way. And like, just in case you think this is hyperbole, this example, it literally happened to someone I know. Like, I had a religious teacher once. And if you're out there, if you're listening to this, you know who you are. I have a religious teacher who actually fell into this false belief. Like, they were at church and their church teacher taught them, faith is really powerful. Whatever you believe can come true if you have enough faith. And then this young boy version of my teacher, he said to his teacher, well, like, If I believe that I can fly, if I believe it strongly enough, if I have enough faith, can I fly? And this teacher told him yes. And so he cultivated his faith in his ability to fly. He cultivated this false belief. And he eventually tested his false belief. And he jumped. And he hurt himself. And you know what? His physical hurt was less than his emotional hurt. Because he felt betrayed. Because someone had cultivated a false belief within him. So not only was he physically hurt, his system of trust was hurt, right? And so that's not a good paradigm. You're just going to create betrayal. You're going to create mistrust. It's bad all over the place. Let's stick to the truth, right? Not the myth of the gods. All right, the next points are kind of fun. He starts to quote William James. William James, a famous American philosopher and psychologist, often called the father of psychology. Kind of a cool guy. Invented the school of philosophy called pragmatism. All right, so William James, he has his own paradigm of free will, and it's based on random creativity. And so his idea is that, the human, the agent, we like random creativity pops up all of these ideas into our mind. And so, option. It's like, brrr, it's like ADHD, but you get all these options in your psychological space. So creativity gives you this random burst of options. And then our willpower navigates these options and selects which one we want. Okay? That's his paradigm of free will. And he's thinking of the random portion as the free portion, and he's thinking of the selection portion as the willful portion. All right. That's a cute paradigm of free will. Let's apply our test, the robotic touchstone. Randomness. Can software do randomness? Yes. That's literally what they're doing all the time. There's a concept of a seed. AI, video games, they're using seeds all the time. Random number generator functions in software, they're using a seed, right? So they're injecting randomness into an algorithm with a random number, and the random number is the seed that pumps variety into the system, right? So it's like, I've got an algorithm, and this algorithm, it goes, step 1, step 2, step 3, step 4, step 5. It's like, but I don't want the same result every time. Okay, so at the beginning of the algorithm, I'm going to give it a random number. So at the beginning of the algorithm, we're going to start with 1,600,253. And so what they do is this algorithm, it's taking that number and says, well, if the number is bigger than 1,000,000, do this. If it's smaller than 1,000,000, do this. If it's got a 1, do this. If it's got a 2, do this. And it just jumbles up the algorithm based on the random number. So we're still in the domain of what robots can do. Now, injecting randomness, incredibly useful. It's like if we want to make a really useful robot, give them a little bit of random numbers. That's powerful, excellent, makes a great agent, right? AI, if we want creative AI art, pump it in with a little randomness. Absolutely brilliant, love it. But we have not transcended the robotic paradigm. We are still slaves to the laws of physics, the structure of the algorithms that are controlling the output, the structure of the random number generator. Where did that randomness come from? Like, there's a system of events that gives you the randomness. You didn't control that system. So you're a slave to what the randomness gives you. That's not what we mean by free will. So just further quoting James on this, James says, our thoughts, they come to us freely, but our actions go from us willfully, showing his, two-step paradigm of free will. But just as I said, you don't control your source of randomness. If you are a slave to your prior conditions, then you are not free. Another point, randomness is helpful for exploratory learning. I got no problems with that. I mean, if you're trying to explore, you want to be a little bit random in your navigation process because that helps you cover more terrain. Yes, absolutely. Inject some randomness. Exploratory learning. Perfect. Beautiful. Still in the robot paradigm. Okay, now this is going to be a little pejorative, but I like being a little bit spicy, right? Okay, so free will of the gaps. There's a family of fallacies that involve something of the gaps, right? Like God of the gaps. And so basically of the gap fallacies, it's basically the idea that there's this complex thing and we're trying to find evidence for this complex thing. And now we have a gap. So the gap is we have a gap in our understanding. It's like, well, we don't understand this part of reality, right? We don't understand consciousness, so we're going to put our special thing in the gap. It's like, this gap is evidence of this thing, right? It's like, no, it's not. So for this free will of the gaps thing, it's like, in our brain, there's some randomness. So we don't understand this randomness. It's a gap in our understanding, right? The brain has a little bit of a gap of randomness. And so free will is this complex thing. And we're just going to say, okay, that randomness is evidence of this free will thing. It's like, that logic doesn't follow. All right, now we're going to be talking about predeterminism. Kevin, he defines predeterminism in the book as the idea that only one possible timeline exists. So it's kind of the idea that alternative timelines are impossible. That's kind of the implication of predeterminism, right? So it's like a domino. Think about a chain of dominoes. One possible timeline means there's only one flow of dominoes and there's no possible alternate flow. Now you could think of intersecting chains of dominoes, and then there's a possibility like, if the domino randomly tips this way, it activates a different chain of dominoes. And then if the domino randomly flips this way, it activates this chain of dominoes. So in a indeterministic domino paradigm, there's multiple possible timelines. So his definition of predeterminism is a single chain of dominoes, excluding other possibilities, right? So the first thing he says about predeterminism is predeterminism makes agency impossible. It precludes agency. All right, so is it true that predeterminism and agency are incompatible? Well, if you conflate agency with free will, then yes. But agency is not free will, and you keep flip-flopping, Mr. Kevin. Because every time you describe agency, you describe something robotic. And robotic things are compatible with predeterminism. But then you conflate robotic things with magical free will, and magical free will is not compatible. So you can't have it both ways. Are we robotic and compatible with predeterminism, or are we non-robotic and not compatible with predeterminism? Pick the one you want. It's not both. Next point. According to Kevin, predeterminism is absurd. Predeterminism is absurd. Okay, that's just an appeal to emotion. It's cute. I mean, sure, it might feel counterintuitive. Like, yeah, but there's a lot of things that are counterintuitive that are true. Quantum physics seems absurd. It's extremely well substantiated by the data. So, yeah, not that good of an argument to appeal to absurdity. Next point. Predeterminism precludes choice. Predeterminism makes choice impossible. Okay, I think this is false. I think choice, if you think about what a choice is, it fundamentally requires a singular selection. Singular, right? So a singular selection is compatible with a singular pathway on a timeline. It's like, here's one dot that is an instance of a singular selection. And then here's another dot that's an instance of a singular selection. And we can chain our choices together such that each choice is a domino that leads to the next. It's like singular choice, singular choice, we've got a singular line of dominoes. I mean, that's compatible with predeterminism in my book. Next point. Predeterminism precludes could have done otherwise. Okay? So free will is often defined as the ability to do otherwise. Yeah, I think that's true, right? If there's one singular pathway, you can't do a different path because there's only one path. Yeah, so that's true, but that doesn't really help the free will argument. I mean, now this is a great argument against compatibilism, right? So he's kind of invoking that he wants the ability to do otherwise. And he's saying these compatibilists, they like determinism, but determinism doesn't give me the otherwise. And so he's like, no determinism. I want my otherwise, right? But if the predeterminism is true, that hurts the free will argument. Okay, but it's debatable. Is predeterminism true, right? So we're still in open territory. All right, this next one's a little tricky. He says predeterminism precludes possibilities, right? So at first glance, it's like, oh, that's kind of true. Huh? I mean, alternative possibilities. It's like if there's only one pathway, it's like you're making the other pathways impossible. Interesting. But the thing is, agency is about simulating potential possibilities, right? And so the agent is simulating, and then it's choosing the pathway that optimizes its goals, right? It optimizes its values. And so because the calculation is deterministic, it has to choose that one single thing. Like the actual choice is forced. So in our timeline, it has to choose the utility maximizing choice. Sorry, that's how it's built. It's built to choose that thing. So it only has one pathway because it has to choose that thing. But there were other simulated possibilities. It's like, oh, does this pathway satisfy my values? Simulate the pathway? No. Does this pathway satisfy my values? Simulate? No. Right? And so there's a sense in which simulated possibilities do exist, but actual alternative possibilities don't. So, semantic. Next point. Predeterminism precludes personal existence. So he's saying predeterminism makes personhood impossible. Okay. I mean, I think he's thinking of it like, well, if it's just determinism, then we're all dominoes and there's no difference between this domino and that domino. We're all just Big Bang matter, right? So it deletes personhood. I mean, okay, but like the thing is, predeterminism is compatible with agency. And agency gives you goals, and those goals function on behalf of an agent, right? And so agents are a slice of the Big Bang that spirals into its own loop of intentional causal chains, right? So imagine the Big Bang as fireworks, and there's a big firework, and then there's a little part of the firework that like evolves into its own trajectory. It's like, okay, it's got a goal and it cycles towards the goal. And there's another part of the firework that cycles towards a different goal. It's like, as long as there are slices of the Big Bang that operate on their own trajectories, i.e. goals, like what's wrong with calling that a self? That a person. So like here's a human, and this human is 37 trillion cells. So it's a little slice of the Big Bang. And these trillions of cells are doing processing and looping of causation, and that looping of causation is looping them towards goals. What's wrong with calling that a self? None of that violates predeterminism. So I do not see the problem here. And I make a little distinction here, like you could have a biological self that is, the biological scope that has a goal. You could have a psychological self, which is like the mental scope that has a goal. Like self is a little bit amorphous. Like it's, semantic. Like how do you want to define it? You can just take a chunk of the Big Bang and say, okay, that's one self. Like, what's wrong with that? I don't see the problem. Next point. Predeterminism precludes self-control. Under this domino paradigm, he's arguing that it's impossible for these dominoes to have self-control because they're controlled by something else. Okay, let's unwind this idea. What is control? So control, it comes from deterministic algorithms. So you need determinism to get control, because cause and effect, the cause controls the effect. Okay, so control is already compatible. Okay, algorithms compatible. Like a thermostat. A thermostat senses the environment. It's, temperature. The temperature is rising. Time to activate the air conditioning. Extremely deterministic. It's controlling itself based on data. Like, okay, control. Not that special. Selfhood, right? We're back to the selfhood thing. Like, the self is just the object that is doing an effect. So the thermostat does the effect. So it's kind of a self in a way. It's like, okay, so the thermostat does the self-control. Like, that's not incompatible with predeterminism. And so you get a more complex self with more complex controls. You get a life form that it's controlling lots of behaviors, so in a way it's self-control, but it's not ultimate self-control. That's the problem. Self-control is agency. Robots can control themselves. That's fine. But the robot is not free from its programming. The robot is not free from the chain of cause and effects that designed it. Neither are we. So, yeah, I think Kevin is wrong to say that you can't have self-control under a predeterministic framework. And compatibilists would agree. All right, next category. This category is called the randomness of the interneurons. Okay, so this is kind of the crux of his neuroscientific argument. So interneurons are the neurons in between the inputs and the outputs. Okay, so stimulus, perception, the data that's coming in, right? The data coming in is absorbed by the senses. That's our stimulus. That's our perception. Okay. We have neurons that absorb the data. Then we have interneurons that process the data. And then we have output neurons that output the actions. Okay. So what does Kevin say? Kevin says the degree of autonomy is based on the loosening of the coupling between perception and action. Okay, so what is he trying to say? He's trying to say that, like, okay, for the knee-jerk reflex, if I hit your knee with the hammer, boom, your leg's going to react. Well, that's a one-to-one relationship, right? Perception, when the hammer hits, that's the perception, boom, the action is the kick. Okay, so what he's saying is, for the knee-jerk reflex, that's not free will, because that's one-to-one. It's a single line of dominoes between perception and action. And what he wants to say is the freedom is in the multiplicity of lines of dominoes. It's like, I hit your knee with the hammer, and it's like, like maybe we kick is one pathway. Well, maybe we think about it. Nah, I'd rather not kick. That's a different pathway. Right? And so what he's saying is, if I hit you with a hammer on your face, there's no knee-jerk reflex. You can think about it. So you get hit in the face. Oh no, I'm scared. I'm not going to move. I'm just going to freeze. It's like, that's one possible pathway. And then I hit you on the face. It's like, well, the interneurons, let's process this. Well, I'm mad. I'm going to fight back. It's like, okay, that's another possible pathway. So the interneurons afford complex, multivariant optionality. It's like, ooh, what's he going to do? It's not a one-to-one. Like, there's some probability here. Like, I can't predict his behavior. Maybe he'll freeze. Maybe he'll fight. Okay, that's cute. But the problem with this paradigm is it doesn't change anything. Like, so electricity is very deterministic. Just because there's multiple pathways does not mean the multiple pathways are not deterministic. The electricity is still following the path of least resistance. Just because there's multiple paths of electricity doesn't mean the electricity is free to violate the laws of physics and go wherever it wants. That's not what electricity does. So the electricity is following the path of least resistance as afforded by the structural configuration, the algorithmic configuration that affords its navigation through the brain. So if you build in your amygdala, if you build a really fearful amygdala, then the electricity is going to go into your amygdala and it's going to get stuck in the fear zone, and then you're going to freeze. And if you don't have a huge amygdala, then the electricity is going to go to the amygdala. It's like, oh, no big deal. And it's going to cycle into the fight cortex or whatever, circuit or whatever. So it's the structure of your brain, your history, all of the times you were beaten as a child. It triggers all this fear in your brain, triggers a freeze response. Like, just because there's probabilities and measurements and two different pathways doesn't mean any of that is free from chains of cause and effect, free from the history of causes filtering down into the structure of an amygdala. Like, loosening the coupling between perception and action doesn't do what you think it does. Next point, and this is kind of a continuation of the same point. It's so the determinism. So we're getting determinism involved, right? So the determinism between perception and action is loosened. So this chain of dominoes is loosened by the indeterminism of the middle layers of the interneurons, right? So then we've got inputs, and then we've got a web of interneurons. It's like, oh, we got a billion different pathways. This way, this way, this way. Ooh, lots of pathways. So many options. I love it. And he's saying, oh, because there's all these pathways, it's the electricity has all these options. And so we've got all this freedom. It's like, well, no. Again, that's not how electricity works. And okay, well, now he mentions indeterminism. Okay, so indeterminism implies randomness. And when you imply randomness, the main way to invoke randomness is to invoke quantum physics. Quantum physics is the go-to source for randomness in physics. Okay, so he's basically appealing to the randomness of quantum physics. He says, in the brain, we've got quantum physics, and the quantum physics gives us randomness so that we can do these different pathways through the brain. Okay, now you've got a stronger argument for true optionality. But do quantum forces actually apply in the brain? I mean, and my understanding is that's a hard no. That's a hard no. The quantum forces cannot be relevant to brain function. Okay, and so now I'm calling this a free will of the gaps argument. Before it was a randomness free will of the gaps. Now we're getting more specific, not just randomness in general. Quantum randomness free will of the gaps. So it's like, ooh, we got this mystery of quantum randomness, and we're going to stick free will in that mystery. So we're just going to assume free will equals this quantum randomness. No, you need to justify your assumptions, not just assert them. That's why it's a fallacy. Okay, so why does this not make sense? That's because the simple answer is because brain signals are too macroscopic. Brains, like neurons, the channels of electricity are too big, right? Quantum physics, the randomness, it only applies at the small layer. It's only the small stuff that's random. The big stuff's not random. Neurons, it's all big stuff, okay? The randomness, it only applies at the level of a single atom in range. Electrons have a little randomness around the atom. That's it. If it's bigger than an atom, the randomness gets canceled out. Because if you have two atoms, it's like, well, you have two atoms. It's like, well, the electron coin flips to the left on this one, and then it coin flips to the right on this one. And so the net effect is the two random electrons cancel each other out. So you have, the bigger you get, the more the quantum randomness cancels itself out. So most people that I have listened to and read, they think that the quantum forces are not relevant at the level of the brain. So I think Kevin, he has the obligation is on Kevin to show us how the brain it invokes indeterminism. Like, you're the neuroscientist here. Where's the randomness in the brain? Show me the evidence that quantum physics actually alters neuronal function, right? That's an important thing if you're going to assert that's where the free will is. Like, show me, right? And, this idea of middle layers, I mean, again, AI models have many middle layers. Like AI models are designed after brains. Like, it's called a neural network in software. They're mimicking all these interneurons, but it's all deterministic. It's all deterministic. They're putting weights on each software neuron, just like our body puts weights on physical neurons. And the weights are what control the flow of electricity. If one neuron has higher weight than another neuron, more electricity is going down the path of weight because it's following the weight, because it's the path of least resistance is pulling it, right? Like, electricity is not free to go wherever it wants. Like, no. Next point. Perception is decoupled from action by the production of meaning. Okay, my issue with this is decoupled is just too strong of a word. Like, he's acting like there's no relationship between the data coming in and the actions going out. No relationship here, because in between we've got all this meaning. Like, meaning doesn't come from nowhere. Meaning comes from a translation algorithm that takes in the data, translates it into meaning. Like, we don't just translate freely. We follow a step-by-step algorithm to translate data. So there's no freedom in that process. Just appealing to meaning does not save you. I mean, you just got robotic agency. That's it. All right, and this next point is where Kevin makes it very clear that he thinks that this affords free will. It's very clear here. Agency provides the decoupling of perception from obligatory action, allowing for free will. Yeah, so I've already argued this point over and over again, beating a dead horse at this point. Basically, he's just saying, oh, it's complex. Like, it's not one-to-one pathway. It's a complex pathway, therefore free will. Sorry, complexity is not good enough for free will. Next point, quantum randomness defeats predeterminism by opening up multiple possible pathways. Okay, I think this is true because predeterminism is the idea that there's just one possible timeline. Quantum randomness can fluctuate us into different timelines depending on where the particles go. Probably true, maybe not true. Like, I think one of the physicists, he has a deterministic view of quantum randomness. So yeah, debatable, maybe true, but regardless, defeating predeterminism does not give you free will. That's just your first stepping stone to free will. It doesn't go all the way. Okay, this next point is kind of complicated, but it's really interesting. So let's try to process this one. Kevin basically says that quantum randomness makes lower level features causally insufficient, allowing higher level features to play a causal role. What the hell does he mean? Let's get this straight. He means lower level features. When we say lower level, we're talking fundamental, bottom up. When we say higher level, we mean emergent, top down. Okay, so what more specific, what is he talking about? Lower level features, he's talking about materials. He's talking about atoms. He's talking about building blocks. He's talking about these atoms are dominoes that control us. Interesting. Lower level features are causally insufficient. Okay, so what he's saying is the dominoes of the atoms do not explain everything because quantum randomness screws up the dominoes. Interesting. Now, he says, higher level features can play a causal role. Because of that randomness, now the high stuff is in control. Whoa, hold your horses. You just made a big leap. Whoa, you need to justify that leap. Show me some deductive logic. How did you get from premise 1 to conclusion? You're missing some premises, bud. Okay, higher level features. What is he talking about? He's talking about agency. He's talking about, the the soul, the psychology, the mind. He's talking about us, ourselves, our personhood, right? He's saying we are a causal role because randomness. Like, whoa, big leap. Rewind. Let's take this step by step. I think this is false because under a predeterminism paradigm, the lower features, they are deterministic, right? You got the particle physics, no randomness under predeterminism, so it's just domino atoms. Okay. Everything is deterministic under predeterminism. Now let's switch. We're going to add some randomness. It's like, predeterminism, we got some problems. Look at this quantum randomness. Well, where is the randomness? It's not at the top. It's at the bottom, right? The randomness is with the atoms. It's not with your brain or with your psychology. So let's start one step at a time. Let's just do it. Half the universe, or atoms, half of atomic behavior is deterministic, half of it is random. This is just, we're playing a little thought experiment, right? Thought experiment, we're creating a universe, all of the building blocks, we got half predictable, half unpredictable, half determined, half indeterminate. Okay, that's our reality. Well, if you want to understand a human, you need to take those building blocks, put them together, and you need to see how the randomness is working. And so the point is that under the randomness paradigm, it's not the top layer that's controlling the causation. It's the bottom layer. So half of the atomic behavior is deterministic. So determinism controls half of it from the lower layer. Randomness controls half of it from the lower layer. And the interaction between randomness and non-randomness is what produces the thing. So my point is the causation, it's sufficient at the low levels. The randomness combined with the non-randomness completely explains the combination. So there's no magic at the top. It's still the bottom up. So I disagree with, this is like his main argument. It's like his main argument for magical agency is that the randomness bubbles up to the brain and now the brain is free. It's like, no, the brain is controlled by the randomness at the bottom. The brain is not free. The brain is either controlled by the determinism or it's controlled by the indeterminism. And the bottom is controlling the top. And then it can be a loop. It's like the bottom controls the top, then the top sends signals to the bottom, and then the bottom controls the top, and then the top controls the bottom. But the top is never free from the bottom because the top is made of bottom stuff. I mean, it's almost like he thinks that our brains have this magical power to top-down control. It's like my mind is reaching down with its magical hand and it's grabbing the atom and saying, you will be random over here. And then it grabs this atom. You will be random over here. It's like, you don't control that randomness? What is this? So how would I summarize Kevin's fallacy this time? The indeterminism free will of the gaps fallacy. He's basically saying indeterminism proves that lower level details do not explain everything. Hence, free will is in the gap where randomness gives flexibility to higher order organization. You gotta do more than that, buddy. All right, so this part is talking about top-down causation. Now it kind of helps his prior points a little bit, but we'll see how it's not sufficient. All right, he says basically higher level configurations can constrain the lower level parts and select among patterns of those parts. What does he mean? Higher level configurations, he's talking about the structure of the brain. Like, this neuron is strong, this neuron is weak. So the electricity is going to flow to the strong neuron. So by the way the brain is built, the electrons are the lower, in the brain it's sodium. So the lower level parts are the sodium. Those lower level parts are being controlled by the structure of these neurons. The big one is pulling the sodium. Cool. Okay. What does that mean? Like, does that give us anything special? No, that does not give us anything special. Okay, why does that not special? It's because the lower level parts respond to their context. So it's true. I think what he's saying is true, is that the structure creates a context that does constrain and control the lower level parts. So in a sense, there's this top-down causation. That's true, in a sense, right? But the problem is, like, where did this structure come from? Like, this structure doesn't just pop out of a box by itself. The structure comes from a long chain of cause and effect. It comes from these lower level chains of causation, right? The higher levels are constructed by the lower levels. So the higher levels are a slave to the lower levels that cause them. So it's back to this looping thing. It's like the lower level causes the higher level, which causes the lower level, circular. So the higher level is not free from this chain of cause and effect. So it's interesting, doesn't do much for free will. All right, this next one's kind of fun. This point, decision-making is based on neurological signals, and we can hack these signals to control decisions. Right? This points to the idea of neural stimulation, right? If I inject a needle in your brain and I zap you with some electricity, I can control your behavior. If I zap you here, different zaps do different behaviors or different experiences, okay? So with the needle, we can hack your behavior. So Kevin is basically admitting, he's admitting that the decision pathways are controlled by causes. And so he's admitting that there are chains of cause and effect that control these decision pathways. And he's saying that we can alter the decisions by altering the chains of cause and effect. So we can make the action a slave to the stimulation. So he's basically arguing that there's no free will because this is all hackable, right? So I don't know if I don't know how he interprets these findings, but reading his book, it felt like he was giving more arguments against free will than in favor of it. Next category, bottom-up causation. In this category, he's trying to say that the bottom-up causes are not sufficient to explain behavior. So he says personality traits don't explain everything in terms of human behavior. It's like, that's true. In psychology, nature does not explain everything. Nurture explains a good deal, maybe half and half. Some is nature, some is nurture. Okay, but what's your point? Like, he's trying to find gaps, right? He's like, oh, personality traits don't explain everything. There's some gaps. We're going to put free will in the gap. Haha, free will is the gap's fallacy. No. So yeah, we have a chain of cause and effect that gives you a personality, your DNA, whatever. We have a chain of cause and effects in our culture. We have a chain of cause and effects in our parenting. We have a chain of cause and effects in our friends. We have webs of cause and effect. We are a complex creature that has a multiplicity of chains of cause and effect. That's what makes us interesting. That's what makes us complex. That's what makes us dynamic. That is not what makes us free. We are not free from any of those influences. All of those things influence us. Now, he argues against himself yet again. He says, reinforcement, right? In psychology, you've got the concept of reinforcement, which is like rewards and punishments. Reinforcement algorithmically controls behavior probabilities. Okay, so he's basically admitting that our behaviors are determined by the chain of cause and effects that came before, that included rewards and punishments, that structured your brain in such a way that you respond in such a way. No free will. You're controlled by all of these things that came before. Okay, reinforcement. Another reason why we are not free from what came before. All right, this next one is really fun. So I took some of his logic and built some syllogisms based on his logic. Now, I'm framing it in a way to make it extra clear what I think is going on. And I don't think Kevin was trying to imply it in the way I'm framing it. I'm showing you where his logic leads counterproductively to his goal. So I'll walk you through the syllogism and then explain Kevin's reasoning. So I'm naming this argument. I think Kevin, he accidentally argued against free will yet again. And I'm calling this the habit argument against free will. Okay, premise 1. Most of our behavior is habitual. Most of our behavior is habitual. We're doing things without thinking. Like half of my hand movements, I'm not even conscious of what I'm doing. I'm just going with the flow. Habit. Okay. Most of our behavior is habitual. Premise 2. Habitual behavior preempts decision making. Okay. So remember the will, free will, it's doing the decision stuff. Well, if you're just habitual, you're not thinking, you're not deciding, you're just doing. So habitual behavior is incompatible with decision making. Okay, interesting point, Kevin. Conclusion. Most of our behavior preempts decision making. Most of our behavior is incompatible with decision making. Okay, next premise, if decision making is preempted, then the will is not involved. No free will here. If the will is not involved, then free will is not involved. Okay, let's combine all this together. Free will is not involved in most of our behavior. Think that through one more time. Free will is not involved in most of our behavior. Kevin accidentally argued that most of our behavior has nothing to do with free will. Okay. Yes, that is what he did. Okay, fine, sure. No free will. Making it harder, buddy. So what I think Kevin was involved in a little bit of motivated reasoning here, because I think he understands that he was arguing against free will. And he basically said, but this is fine. It's great. It's great to not have free will because habits make our life better. Like habits give us well-being. It's like, oh, I'm eating my food. Well, I don't want to have to decide how to micromanage my tongue. Like, let's just let habits do it, because I can live a carefree life if I just do the habits. So he's like, yeah, the no free will is great. Habits are awesome. It's like, no free will is great. Huh. Interesting. If no free will is so great, then why are you struggling to accept it? All right, this is a cute argument, but ultimately also a failure. He basically says we have some control over the configuration of our psychology because we were involved in developing our psychology. Okay, I think this is a useful perspective, and I respect it as a useful perspective because it's probably true, and it is an empowerment of the individual to change, to grow, to evolve. And our brains, we can adjust the weights on our neurons, and we can create new pathways, and we can, we're not stuck in a rut. Change is absolutely possible. And so we should not interpret no free will as, oh, things will never get better. I'm always going to be the same. No, that's not what it is. Because of the algorithms, those algorithms can improve. And so no free will doesn't mean you can't improve. Okay, so that's great. That's hopeful, right? Cool. Awesome. That's agentic. That's not free. Why? This process of developing our psychology, that process is not free, right? So our psychology today is constructed yesterday. Okay, let's go back in time yesterday. Well, yesterday's psychology was constructed the day before. And so none of these days of psychology are free. They're all, it's part of the domino effect of billions of factors. It's like, oh, does this affect me? Oh, no. Does that affect me? Oh, does this motivate me? No. Yeah, that motivates me. Okay, I want to change. Okay, I want to strengthen this neuron. Okay, I want to build this neuronal pathway. It's a cycle of influences that are slowly molding you, but none of it's free of causation. It's an evolving storm of causation. Okay. So, yeah. Next point. Kevin says, we are not slaves to our psychological predispositions. Okay, so this is he's kind of vaguely pointing to a gap again. Okay, so I can agree. Let's just agree. Okay, we are not slaves to just our psychological predispositions, because that's not all there is. There's a storm of causation. It's not one single line of causation. Okay, so we're not slaves to just our psychological predispositions. We're a slave to a variety of things. And all of those things are causally comprehensive when we aggregate them. It's like, environment. Within the environment, there's parents, friends, schooling, culture, language, all these different causal chains. Then within our DNA, there's all these different causal chains. Prenatal environment, all these causal chains. Nature, nurture. Okay. So when we add together all of nature and all of nurture, that is causally comprehensive. That's all of it. There's no, so it's like when we do like science, we do some biology, psychology, do some experiments, we can kind of do percentages. It's like, okay, 50% was nature, 50% was nurture. Cool. Where's the free will percentage? No, it's causally comprehensive. Next point, readiness potential is only discovered on non-consequential choices, like pressing a button. This is one of the classic studies in the science of free will, where it's like we can see the decision on scanners before you actually do it. And so there's a little graph of your metrics, and it's like, oh, your body has a readiness potential. Your body knows what you're going to do before you do it, and so therefore no free will. I don't know. It's a complicated topic. I don't think readiness potential is that important for the free will argument. And it kind of boils down to causation. Like, okay, choices, actions, there's chain of cause and effect, right? If maybe it's caused by the readiness potential, maybe it's caused by consciousness, maybe it's caused by some other potential. Like, it doesn't matter what the cause is, it matters that there is a cause, right? If there is a cause, and that necessitates more causes, and that necessitates slavery to a chain of causes, then there's no free will. So this argument only works if you can debunk chains of causation in general, not just one specific chain. And as far as I know, nothing in the universe is free from chains of cause and effect. Except maybe at the quantum physics level. Debatable, but not relevant. All right, last category of topic, morality and responsibility. Kevin basically says he thinks that morality and legal responsibility need not change because we do have free will. Okay, I'm not convinced by Kevin's argumentation that we have free will. But I do think that, like moral and legal responsibility, I think you could probably argue that those could be rested on a foundation of agency, not on a foundation of free will. What does that mean? I don't think you need free will to be put in jail. I think having agency is sufficient to be put in jail. Or at least it's debatable. Like, we can have a separate debate about morality. I don't think, there's more to be said on the morality topic. But basically, I think it's perfectly reasonable to debate whether or not we should lock up murderous robots in jail. Like, if there's a bunch of wild robots killing people, like, we should probably stop them. Like, we don't care if they have free will. Like, you're a deterministic robot, you have some broken programming, or you have some harmful programming, and it's hurting us. We don't want to be hurt, so we're going to lock you up. What's wrong with that? Like, there's an agent. It's acting in the world in a bad way. It's causally responsible. Like, its programming is the source of its deterministic behavior. So I'm skeptical of the idea that we have to throw away morality and legal responsibility, because I think agency is a real thing. So that's my thought on that. All right, let's get to the conclusion of the book. Kevin, he quotes Sam Harris. Sam Harris has a clever little line here. Sam Harris says, "A puppet is free as long as he loves his strings." Well, what is the context? Sam Harris is caricaturing the compatibilist position. He's saying that the compatibilist philosophy reduces to this phrase. The compatibilists think free will is puppetry. It's like humans, we're puppets to determinism, right? The strings of physics are puppeteering all of us. And the compatibilist says, I like my determinism, therefore this is fine. Like, I accept that I'm a puppet, and this is free will. So Sam Harris is kind of highlighting the absurdity of the compatibilist position. It's like, puppets are like the stereotypical definition of lacking freedom. And you're just defining your freedom as equivalent to the antithesis of freedom. Like, how absurd! It's like, cool, okay, great point. What's your response, Kevin? And Kevin goes, well, but selfhood requires strings. So he's basically embracing the compatibilist absurdity. It's like, yeah, but we need to be controlled. It's like, how are you not seeing the problem? You need to be controlled. No free will. No free will. Why is this so hard? Like, is your ego so big that you can't accept that the laws of physics are more powerful than you? Is that too hard to accept? I mean, it's just the truth. Like, we have to embrace the truth in order to figure out how to navigate to goodness. Like, let's stop with these fairy tales. This last point here is basically Kevin's conclusion of his entire position, the entire book. He sums it up in one sentence. He says, if free will is the capacity for conscious, rational control of our actions, then I am happy in saying we have it. Interesting. Okay, what's the problem with this? He kind of just sneaks in consciousness and rationality into his conclusion. Like, these are two complicated topics that need to be dissected. Like, what is consciousness? What is rationality? He's just kind of asserting that our will has these things. And, to be fair, like, there's ways of interpreting him that maybe when he talks about interneurons, what he means is consciousness. Maybe he means maybe he's meaning rationality when he talks about reasons. Okay, fine. But still, there's more problems here. So when we're discussing like philosophy and the way reality works, we don't really care if Kevin is happy to say we have free will. So using the word happy in your conclusion, it kind of screams motivated reasoning. Like, I have a bias to believe in free will. It's like, thanks for showing your hand. Like, okay, we don't care if you're happy. We care about the truth. Well, that's what we should care about. I mean, in this context, right? Obviously, we want you to be happy, Kevin. Sorry, I've been hard on you this video, man. You're a cool guy. You're a smart guy. If you want, we can talk about this. But it's obvious I disagree. Yeah. The Big Bang made me the way I am. I'm sorry. I can't control the fact that I disagree. Okay, so we don't care if Kevin is happy about these propositions. What we want are good reasons for or against the proposition. Do we have free will? I don't think Kevin has given us good reasons to say we have free will. I think he's just kind of bounced around between free will and agency and getting confused between the two, and mostly arguing for robotic agency, but then trying to say that we're not robots. All right, let's bring in consciousness, because he brought in consciousness. Okay, consciousness has been proven to be a slave to chains of cause and effect. Consciousness is not immune to determinism. As I've mentioned, and Kevin did not talk about neural stimulation very much. Neural stimulation, we can produce conscious experiences with the needle in the brain. Okay, so that means we control the causal chain that creates consciousness. Consciousness is a slave to the needle. Okay, so there's no free will with consciousness. Like, there's no get out of jail free card here. Kevin snuck in rationality. Okay, let's talk about rationality. Rationality is basically logic, and logic is basically algorithms. And algorithms don't give you free will, so rationality does not give you free will. So just sliding that in there does not argue for you, does not give you what you're claiming. All right, the biggest problem with Kevin's conclusion is he says if free will is the capacity, right? So he's proposing a definition. If this is free will, I'm happy in saying that we have it. That's a big problem because that's not what free will is. At least I'm strongly against such a definition because it's a compatibilist definition, and compatibilism is saying robots have free will. And that's dumb. Okay, so free will is not conscious rational control. Free will is a decision-making process whereby the self is free to do whatever it wants without being controlled by chains of cause and effect. Conscious rational control is something that meat robots can do. The meat gives you the consciousness, and the robot gives you the algorithms, and the algorithms give you the rationality. So conscious rationality, meat robot, that's all you're saying. You're saying if free will is meat robot, then we have free will. Free will is not meat robot. Free will is something that transcends meat robot. So if a robot can do it, it's not free will. Now, if you want to change the definition of free will, you need to tell me why we should change the definition of free will to meat robot. Because nobody thinks of them, nobody says, like, that's not what the majority of people think. Oh yeah, I'm a robot, that's free will. Like, no, it's the opposite of free will. So yeah, if you're interested in any of these points, you can go through. I tried to label everything, like here is point 37. You can scroll down the references to see the quote that I'm referencing. You know, quote 37 references to this line right here. So feel free to explore this and tell me if you disagree with any of my interpretations of Kevin's work. But yeah, that is my perspective. Hope you enjoyed that. And if the Big Bang allows, like and subscribe.